Hello, my name is Professor TK the Chemist. So, the importance of water. Speaking of water, which is something that we should take daily, there are things that you're going to learn that you did not know as it relates to that topic. The overview topics that we're going to discuss deals with polarity of water, adhesive and cohesive properties of water, heat and energy properties, water as a solvent, and its connections to the nurse and healthcare profession so that you guys can understand why we need to know how water relates to the medical field. Let's get into it. The polarity of water is defined as a polar molecule, meaning it has a partial positive charge on one end, hydrogen atoms, and a partial negative charge on the other end, oxygen atoms. And what you will see on the screen is an example of these polar bonded molecules. So when you have your hydrogens attached to your oxygen molecule, you're forming a polar bond. And why is that? Because of the slightly negative charge of oxygens due to its higher electronegativity. Hydrogen atoms have a slight positive charge. Now, as a visual, let me find this here on my desk. Give me 1 second. This is the visual here. As you take a look, okay, you will notice that there is the oxygen molecule in the middle, and then which is red, and then you have your two white molecules on the ends. This deals with the polarity of water, how there's a tug of war for that atom that's in the middle, that oxygen atom that's in the middle. So it's battling both ends of hydrogens. Just a little fun side to observe. Hydrogen bonding. Hydrogen bonding is when the polarity allows water molecules to form hydrogen bonds with each other. The importance of this shows you how it has high surface tension, capillary actions, and other unique properties. Now, when you talk about covalent bonds, this is when you have a non-metal element attached to another non-metal element. And in this particular case, you have hydrogen attached to oxygen. Both of those are non-metal elements. But to be more specific, when we say polar covalent bonds, that just simply means that one is positive and the other one is negative, and they're both nonmetals, such as this case here with hydrogen and oxygen being attached to each other. If we discuss hydrogen bonding, those would be nonpolar covalent bonds because they're both positive positives, or basically the same element attached to itself. There are 7 elements on the periodic table that are classified as such in terms of being nonpolar covalent bonds. So if you have an element that's attached to itself, that's nonpolar covalent. Hydrogen, oxygen, iodine, bromine, chlorine, fluorine, just to name those few. Coming up, we're going to give you a quiz. Are you ready? Let's go ahead and see what you know as it relates to the first couple of slides of information that we discussed on water properties. Question number 1. What makes water a polar molecule? A, equal sharing of electrons between hydrogen and oxygen. B, unequal sharing of electrons between hydrogen and oxygen. C, water molecules have no charge. Or D, water molecules are linear in shape. The answer is B, unequal sharing of electrons between hydrogen and oxygen. Remember, oxygen and hydrogen have an unequal balancing of electrons. If you notice in the first couple of slides, hydrogen has a positive charge, oxygen has a negative charge. So there are unequal shared pairs of electrons. If you think about water molecules having no charge, we know that that is also incorrect because there is a charge between hydrogen and oxygen molecules. And then for letter D, where it says water molecules are linear in shape, that is also incorrect. Water molecules are actually bent in shape. Question 2. Which property of water allows it to form hydrogen bonds? A, high specific heat, B, polarity, C, high heat of vaporization, or D, cohesion? The answer is B, polarity. Polarity is the correct answer because it is a characteristic of water molecules that allow hydrogen bonds to form. If you also think about water's polarity, it is the reason why hydrogen bonds form as a result. Now, let's look at the reasons why letters A and C are incorrect. High specific heat and high heat of vaporization. Those are the results of hydrogen bonding, not causes. Remember, cohesion is an effect of hydrogen bonding, not the reasons hydrogen bonds form. Whilst water's high specific heat is a result of hydrogen bonding, it is not the property that allows hydrogen bonds to form. Instead, high specific heat is a consequence of the energy needed to break hydrogen bonds during heating. Cohesion and adhesion. One thing you need to remember is that cohesion is basically the attraction between water molecules due to hydrogen bonding. It's just that simple. But adhesion means it's the attraction between water molecules and other substances. So as an example, when we think about cohesion, this is like the property that's crucial for processes like water transport in plants. And whereas adhesion is where you have water molecules that also stick to other substances. So this property helps water to climb up plant roots and stems. Again, if we think about cohesion, that results in high surface tension. So some examples or real life examples of cohesion, think about water droplets that form beads on a surface, or surface tension allowing insects to walk on water. Adhesion, they're responsible for capillary actions. And as I said before, water moving up plant roots and stems are an example of that particular process. Or you can think of a meniscus formation in a graduated cylinder. So if you look at a graduated cylinder in any science lab, there's a little curve right below the numbers where that mark is to tell you how much liquid is inside. So if you think about the little curve that you see, that deals with adhesion. You know what's coming up? Quiz time. Question 3. What is cohesion? A, attraction between water molecules and other substances. B, attraction between molecules of different substances. C, attraction between water molecules. Or D, water's ability to dissolve other substances. The correct answer is C, attraction between water molecules. Remember, cohesion is the attraction between water molecules due to hydrogen bonding, whereas for adhesion, it's the attraction between water molecules and other substances. So for letter A and letter B, where they tell you that attraction between water molecules and other substances and attraction between molecules of different substances describes adhesion, not cohesion. Water's ability to dissolve other substances, which is the answer for letter D, describes solvent properties of water, not cohesion. So again, letter C, attraction between water molecules is the reason, because water molecules between each other simply means cohesion due to hydrogen bonding. Question number 4. Which of the following is an example of adhesion? A, water forming droplets on a leaf. B, water forming a meniscus in a graduated cylinder. C, water molecules bonding to each other. Or D, ice floating on water. The correct answer for question 4 is B, water forming a meniscus in a graduated cylinder. Here's why. Water forming droplets on a leaf and water molecules bonding to each other are examples of cohesion. That's why letter A and letter C are incorrect. And for letter D, ice floating on water, that's due to density differences between solid and liquid water, not dealing with adhesion. Now, you just took a 4-question quiz on properties of water so far and what you've learned about cohesion and adhesion. Now we're going to get into high specific heat capacity and the importance of this and why you need to know it. So let's get into what you're going to actually see on your screen. There is a table that deals with specific heats of common substances. And then there's another illustration of how all of these different forms of water can actually occur. But you need to understand why this is important for the TEAS exam. So let's give you all a definition of these vocabulary words. High specific heat. This means water can absorb a lot of heat before changing temperature. An example of that would be to stabilize temperatures in organisms and environments. This is important because this property helps regulate temperatures in the environment and in living organisms, providing a stable climate also and body temperature. The next definition, high heat of vaporization. It takes a lot of energy to convert water from liquid to gas. This is important for cooling mechanisms like sweating. We discussed this in prior units where you had to know the differences between solids going to liquids, liquids going to gas, and so forth. So with heat of vaporization, which means again water requiring a significant amount of energy to change from liquid to gas, this is important because it allows for efficient cooling mechanisms in organisms such as sweating and also transpiration in plants. Have you ever heard that water is a universal solvent? That's right, y'all. That is due to its polarity. Water can dissolve many substances, such as ionic compounds and polar molecules. They dissolve well in water. And let me tell you guys why this is important. Number one, it's essential for chemical reactions in living organisms. And number two, it helps to facilitate transport of nutrients and waste in biological systems. Polarity, for instance, with water's polarity, it allows it to interact and dissolve various solutes effectively. Solutes are typically solids like salts, sugars, etc. Hydrogen bonding. The ability to form hydrogen bonds helps break down water complex molecules. And another thing, when you think about these dissolution of ionic and polar substances, water can stabilize and dissolve ionic and polar substances, making it a versatile solvent. Y'all, when you talk about water, you think, gosh, not only should we drink it, a side note, you have to be very cautious also when you're drinking a lot of water because water, while we say it's a universal solvent, it can also play a role in having one deplete a lot of the minerals that your body needs. So if you're taking medication and you're drinking too much water, you may have a downside in terms of dissolving too many of the minerals and important properties of that medication. Now, when I mentioned how polarity of water allows water molecules to surround and interact with other solutes, effectively dissolving them, think about salt, okay? When you have salt, adding it to water, the positive part of water molecules, like the hydrogens, surrounds the chloride ions. And then the negative part of oxygen surrounds the sodium ions. And that leads to the dissolution of salt. Tongue twister. Now, you also should know that water's ability to form hydrogen bonds enhances its solvent properties. Why? Well, again, hydrogen bonds are weak attractions between the hydrogen atom of one water molecule and the oxygen atom of another. Again, this interaction helps break down complex molecules. Another great example of this is sugar water. Now, the reason why I bring up sugar water is because So many people love to add sugar to Kool-Aid or to their tea. Sugar dissolves in water. Why? Because water molecules form hydrogen bonds, and the hydroxyl groups, the OH in water, pulls those sugar molecules apart into individual glucose or fructose molecules. In case you didn't know, now you know. And lastly, many minerals and nutrients such as calcium and potassium dissolve in water, making it crucial for biological processes like nutrient transport in blood and cellular functions. You know what time it is? Quiz time. Question 5. Why does water have a high specific heat? A, because it is a polar molecule. B, because it forms hydrogen bonds. C, because it can dissolve many substances. Or D, because it has a high heat of vaporization. The answer to question 5, why does water have a high specific heat, is B, because it forms hydrogen bonds. Let's take a look at why the other answer choices are incorrect. Letter A, because it is a polar molecule. Well, polar molecules and solvent properties are important characteristics of water, but do not directly explain its high specific heat. For letter D, where it says, because it is a high heat of vaporization, high heat of vaporization is a result of hydrogen bonding, but not the cause of high specific heat. And then letter C, because it can dissolve many substances. Well, let's go a little further with that particular answer. B says because it forms hydrogen bonds, that is the primary reason, because water has a high specific heat as they require considerable amounts of energy to break and absorb heat without a large temperature change. Now, keep in mind that because it forms hydrogen bonds, water has a high specific heat because of the extensive hydrogen bonding between its molecules. Now, when heat is added to water, much of it is used to disrupt those hydrogen bonds before the water molecules can increase in kinetic energy, thus creating the rise in temperature. We discussed this also at the very beginning in one of our other units when we talked about all of this. So keep in mind, guys, that as we go through these types of TEAS questions, you're going to have to know prior information that leads you to this discussion. There's connections between each unit on your test, okay? And finally, again, to further elaborate on letter B in terms of forming those hydrogen bonds, remember, hydrogen bonds means that water can absorb a lot of heat without a significant increase in temperature, thus giving it a high specific heat capacity. Now, speaking of that, we're going to take a look at a chart that deals with high specific heat capacity and what it means in terms of solubility and temperature. Stay tuned. Here is your last question within this category. Question 6. Why is water considered the universal solvent? Is it because of A, because it can dissolve only polar substances? B, because it can dissolve only non-polar substances? C, because it can dissolve many substances, both polar and ionic? Or D, because it can only dissolve gases? The correct answer is C, because it can dissolve many substances, both polar and ionic. Remember, likes dissolve likes. Water is a polar covalent bond. So when you think about polar covalent bonds and ionic bonds, they are similar in terms of positive and negative charges. So when you look at letter B where it says, because it can dissolve only non-polar substances, that is incorrect, because polar means positive and negative. Non-polar means they're either both positive positive or negative negative. So we can discount letter B as the answer. Letter A says only dissolve polar substances. No, it can dissolve both polar, and ionic. And then letter D says because it can only dissolve gases. Again, that is not true either. Remember, solutes are typically the substances that water tends to dissolve. Solvents, your universal solvent, is water, and it typically, on most occurrences, will dissolve things that are considered to be solute, meaning solids, not gases. Now, you remember when I said this was the last question, right? Well, this is a bonus question, and that is question number 7. What property of water allows insects to walk on its surface? Letter A, high heat of vaporization. Letter B, adhesion. Letter C, high specific heat. Or letter D, high surface tension. The correct answer is D, high surface tension. Remember when we discussed two key vocabulary words, cohesion and adhesion. Cohesion means water droplets forming on beads of a surface, or surface tension allowing insects to walk on water. That deals with cohesion, meaning that's why we allow insects to actually walk on its surface. But adhesion, on the other hand, means that water moving up plants or stems, and meniscus formations on a graduated cylinder, that deals with adhesion. So again, what property of water allows insects to walk on its surface deals with high surface tension. Now, there's this other concept that you all need to know, and that is the importance of understanding water properties as it relates to two concepts, biological significance and its chemical solutions. So, the biological significance is water's property being crucial for life processes such as temperature regulation, nutrient transport, and metabolic reactions. For chemical solutions, on the other hand, you need to understand water's role as a solvent in terms of how it helps to study these solutions, because you need to know how solutions are prepared by understanding the solubility and reaction mechanisms. Now, you're probably wondering, how does this graph relate to water properties? Let's get into that process. The solubility curve that you see illustrates how the solubility of a substance changes with temperature. So for most solids, solubility increases with temperature because higher temperatures provide more kinetic energy to break the intermolecular bonds in the solute and solvent, leading to increased dissolution, meaning dissolving abilities, okay? So when you think about water's high specific heat, there's that vocabulary word again. What you need to know is that it means it can absorb a lot of heat with a minimum increase in temperature, allowing gradual and controlled changes in solubility. This property ensures that aquatic environments and biological systems remain stable despite temperature fluctuations. So we know that this also relates to our aquatic life, those little fish and those little sea animals. They're important too to this process. And by looking at how they respond, it also in turn helps us to understand our own mechanisms, biological functions as well. Let's take an example of the solubility curve for potassium nitrate. As you guys can see, it's listed right here on the curve, and I'm highlighting it now so you all can see that. Right there is that bluish line right there, okay? So what you can observe is that the solubility of potassium nitrate, KNO3, in water increases significantly with temperature. So look at the bottom here where your temperature is on the very bottom from 0 to 100 degrees Celsius. The solubility is on the y-axis where you see the grams of the solute per grams of water, okay? So notice those numbers increase. So if we started at like 10 degrees Celsius, as we increase the temperature, the solubility also increases, okay? So that is one thing that you guys can keep in mind, that as water molecules move faster and interact more effectively with potassium nitrate molecules. It's overcoming lattice energy more easily due to that increased kinetic energy. So we have two last questions to ask you as it relates to the solubility curve of various solutes. Question number 8. How does water's polarity affect its ability to dissolve ionic substances? Is it because of A, it decreases solubility, B, it increases solubility by stabilizing ions, C, it has no effect on solubility, or D, it makes water a non-polar solvent? The correct answer is B. It increases solubility by stabilizing ions. Let's explain why the other three answer choices are incorrect to further explain why letter B is the correct answer. First choice, A, it decreases solubility. The reason why this is incorrect is because water's polarity actually enhances its ability to dissolve ionic substances. The positive and negative ends of water molecules interact with ions, facilitating in this dissolving rather than decreasing it. Letter C, it has no effect on solubility. Well, this is also incorrect because water's polarity has a significant effect on its solubility. The polar nature of water is crucial in dissolving ionic compounds, so saying it has no effect is inaccurate. And then finally, letter D, it makes water a nonpolar solvent. Again, this is incorrect because water is a polar solvent due to its molecular structure. Its polarity is what allows it to interact effectively with other ionic substances. Okay? So when we look at letter B and we know that it's increasing solubility by stabilizing ions, remember, water's polarity affects its ability to dissolve ionic substances by stabilizing it. When ionic compounds dissolve in water, the positive hydrogen ions of the water molecule surrounds that negatively charged ion, and then that negative oxygen atom surrounds the positively charged ions. So again, this process helps to separate and disperse ions throughout the solution, thus increasing its solubility. And finally, the last question in this series, question number 9. Why does the solubility of most solids increase with temperature in water? Is it because of A, water's density decreases, B, water's hydrogen bonding decreases, C, because higher temperatures increase kinetic energy, breaking intermolecular bonds, or D, because water's cohesive properties decreases? The correct answer is C, because higher temperatures increase kinetic energy, breaking intermolecular bonds. Let's discuss why letters A, B, and D are incorrect so we can further evaluate why C is the correct answer. So for letter A, because water densities decreases, well, that's not correct because while water's density does decrease slightly with temperature, this change is not the primary reason for increased solubility of solids. Solubility is more directly related to the interactions between solute and solvent molecules rather than the density of those solvents. And then for letter B, because water's hydrogen bonding decreases, again, that's also incorrect because hydrogen bonding between water molecules does decrease slightly with increasing temperature, but that is not the main factor affecting the solubility of solids. The increased kinetic energy and the disruption of solute-solute interactions plays a more significant role. And then finally, letter D, the reason why that is also not the correct answer is because the cohesive properties of water due to hydrogen bonding do decrease slightly with temperature, but that is not the primary reason for the increased solubility of most solids. As a matter of fact, the solubility is mainly influenced by the increased kinetic energy that helps to break intermolecular bonds within the solids. So when you look at letter C, as the correct answer, as temperature increases, the kinetic energy of both the water molecules and the solute molecules increase. So this additional energy helps to overcome the intermolecular forces holding the solute molecules together in the solid state. So when these bonds are broken, the solid molecules can more easily disperse and interact with the solvent molecules, thereby increasing solubility. Okay? So, as we wrap up our questions and on this series, I'm going to give you guys some more practical reasons why this whole unit, while it was very large, why you needed to understand water properties, especially for the TEAS exam. So, in conclusion, understanding water properties is essential for the TEAS exam because it reinforces many of your biological and chemical processes which are crucial for healthcare. Water's polarity, cohesion, adhesion, high specific heat, and solvent abilities explain fluid balance, nutrient transport, and temperature regulation in the body. These concepts are fundamental for administering IV solutions, medication dosing, and interpreting lab results, all of which are critical skills for nursing and healthcare professionals. Mastery of these topics ensures that students can effectively apply scientific principles to real world medical scenarios. Good luck on your TEAS exam. If you need further assistance, please take a look at all the other concepts that we are going over within each unit for the TEAS exam for science. Take care and stay tuned for our next video as we assure you success with flying colors for your TEAS exam.